YouTube channel where every episode I take a physics topic and hopefully explain it in a simple and understandable way. Some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. Today's episode is all about stopping distances. Beep beep. Right, so the stopping distance of a car is the distance you travel in the time between the driver first spotting the hazard and the car coming to a complete stop. In an emergency, so like a hazard ahead in the road, the driver would have to perform an emergency stop. It's pretty scary stuff, so all the better that you know the science behind it. An emergency stop is where the maximum force is applied by the brakes in order to stop the car in the shortest possible distance. I've only ever done one of these in my driving lessons, and they are pretty intense. The longer it takes to perform the emergency stop, the higher the risk of crashing into whatever is in front of you. So here we go, the equation you all need to remember. And remember it well, my friends. Stopping distance equals thinking distance plus braking distance. Repeat it again. Stopping distance equals thinking distance plus braking distance. And now whilst balancing an apple on your head. Stopping distance equals thinking distance plus braking distance. Now whilst doing a handstand. Stopping distance equals thinking distance plus braking distance. And now, no, I'm only joking. Hopefully you've got it by now. Okay, so the first half of the equation is thinking distance. Thinking distance is the distance that the car travels in the time between the driver noticing the hazard and applying the brakes. Thinking distance is affected by two main factors. These are 1. How fast you're going. So the faster you're going, the further you'll travel in the time it takes you to react. Of course. And the second is the driver's reaction time. So the longer the reaction time, the longer the thinking distance. Now this is affected by things like tiredness, old age, alcohol, inexperience. Reaction times are not only different depending on the person, but every person will have a different reaction time depending on the time and the day it is. These are really variable. So yeah, that's thinking distance. Now for the second half of the equation, braking distance. This is the distance the car travels during its deceleration whilst the brakes are being applied. In simpler terms, it's the distance travelled between the brakes being applied and the car coming to a complete stop. There are some typical braking distances that have been published by the Highway Code. So at 30 miles an hour, the typical braking distance is about 14 metres. And at 50 miles an hour, it's about 38 metres. And then at 70 miles an hour, it's about 75 metres, which is scarily long. And we haven't even added thinking distance onto that yet. But we'll do that later as some examples. The braking distance is affected by 4 main factors. Yikes. The first being how fast you're going. So the faster you're going, the longer your vehicle will take to stop. The second factor is how good your brakes are. If the brakes are worn or faulty, they won't be able to apply as much force as the well-maintained brakes, which could be awful in an emergency stop situation. The third factor is the mass of the vehicle. So with the same brakes, the larger the mass of the vehicle, the longer it will take to stop. So the car will take longer to stop if you have more people in it or loads of luggage or something. And lastly, the fourth factor is how good the grip is. This can depend on the road surface. So if there are leaves or oil on the road, there is less grip. So therefore there's less friction between the road and the tyres, which can cause the tyres to skid. The grip also depends on the weather conditions. So if it's wet or icy, there is also less friction between the tyres and the road. And lastly, the condition of your tyres will affect your grip. So if your tyres are worn or bald, so they have no tread left, you will have less grip. And they also can't get rid of water in wet conditions, which can cause skidding on water. There we have it, the 2 parts to the stopping distance equation. Let me run through 2 examples with you just to triple check we all understand. I told you earlier that at 30 miles an hour, a vehicle will have a braking distance of about 14 metres. If the thinking distance is 9 metres, then what does that make the stopping distance? Well, when we add them together, we calculate that the stopping distance is 23 metres, which is about 6 cars long. Cool. And whilst going 70 miles an hour, the braking distance is roughly 75 metres. If the thinking distance is 21 metres, then this must mean that the stopping distance is 75 metres plus 21 metres, which makes 96 metres, which is about 24 car lengths, which is mental! And it just shows how crucial it is for drivers to leave enough space between their car and the next car in front of them, so that if they need to stop suddenly, this can be done safely. And it also shows that enough space changes depending on the speed you're going at. So the faster you're going, the longer your stopping distance will be. The faster you're going, the longer your stopping distance will be. The faster you're going, the longer your stopping distance will be. The faster you're going, the longer your stopping distance will be. Thank you for listening. I hope you enjoyed it. If you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I will try to do a video for you.